Up to this point, we've configured the Google Cloud for the weather clock, and all that remains is programming the IoT kit. Previously, we've used a stepper motor driver, which can control the speed and direction. The source code discussed in this video can be found on Atmel Start. Click on Browse Examples, select the AVR IoT board, and find the AVR IoT WG sensor node with stepper 2 click. When the example is opened, change Example Selection to Weather Clock. When you now generate the project, it will have the weather clock source code. The weather clock requires precise stepping to a given position, for instance, move to 180 degrees. In our video on stepper motor theory, we discussed the concept of a step angle, which is how many degrees the motor rotates for every step. The Adafruit motor has a step angle of 1.8 degrees, giving us 200 possible positions. In other words, if we give the stepper motor 200 pulses, it rotates one full rotation. We implement the go-to-position function to move the clock hand to the desired position. It takes in a target position, which is a number between 0 and 200. Based on the current position of the clock hand, it rotates the appropriate number of degrees to reach the desired position. The stepper 2 click executes one step for every pulse it gets on the step pin. To keep it simple, we can toggle the step pin manually to get the desired number of steps, as such. The question now is how many steps do we need to take, and are we rotating clockwise or counterclockwise? We always want to rotate the shortest distance. For instance, if we are at 90 degrees and are moving to 180 degrees, it should move clockwise. Likewise, if we are at 180 degrees and want to move to 90 degrees, it should rotate counterclockwise. This is our shortest path problem, which we can solve with modular arithmetic. A circle wraps around at 360 degrees. For instance, 360 plus 90 equals 90. This is modular addition. The shortest path is therefore calculated using the displayed equations. Notice we are using 200 and not 360. This is due to the step angle, giving us 200 position and not 360. In a previous video, we configured the cloud to send a JSON message to the device with the current format. We parse this message the same way we parse the speed message from video 4 of the Getting Started series. When the desired position has been received, we pass it into the go-to-position function we just created. The final step is to configure the Atmel Start project to use our cloud project. Right-click on our solution and select Reconfigure Atmel Start project. Click on AVR IoT WG sensor node and change the cloud configuration fields to the respective correct values. When finished, click on Generate Project. When a project has been generated, it can be flashed onto the AVR IoT board. The clock housing, lid, and point-through 3D files can be accessed on GitHub. See the link in the description. If you have access to a 3D printer, you can print these out and assemble the clock. This concludes the video series on the weather clock. If you'd like to read more details, a user guide document covering the weather clock can be found in the description below.